The F-35 Lightning II is a distinctive fighter aircraft with a unique design optimized for its ground attack role while incorporating stealth characteristics. It shares a similar appearance to Lockheed's F-22 Raptor, another fifth-generation fighter, but is smaller in size due to its single Pratt & Whitney engine. This design choice sacrifices some straight-line performance compared to the F-22, but enhances its capabilities for ground attack missions, aligning it with aircraft such as the F/A-18 Hornet, F-16 Fighting Falcon. The fuselage of the F-35 features angular and sharply tapered edges, contributing to its stealth profile. The cockpit is positioned behind a short nose assembly housing the radar, and it has a unique forward-hinged two-piece canopy. The aircraft accommodates a single pilot and does not include a traditional head-up display in the cockpit. The intakes are located on either side of the forward fuselage and are angled inward to improve stealth characteristics. The high-mounted wing mainplanes have greater sweep along the leading edge and less sweep along the trailing edge, with clipped tips near midships. The split intakes supply air to the single engine located in the rear of the fuselage, which exhausts through a single ring-shaped nozzle. The empennage consists of outward canted vertical tail fins, while the all-moving horizontal planes extend past the exhaust port. The retractable undercarriage includes two main single-wheeled landing gear legs that retract into the fuselage sides, and a single-wheeled nose landing gear leg that retracts forward under the cockpit floor. Notably, the F-35 lacks conventional externally mounted probes and vanes, which are internalized to maintain its stealth capabilities. In terms of armament, the F-35A variant is equipped with the GAU-22/a 4-barrel 25mm cannon, carrying 180 rounds. The F-35B and F-35C also feature this cannon, but with an external mount and 220 rounds. The cannon pod itself incorporates stealth design elements to reduce the aircraft's radar signature. To maintain its stealth characteristics, the F-35 typically carries its primary ordnance internally in bomb bays, while optional external underwing pylons provide additional weapon-carrying capability. The aircraft can accommodate foreign-borne weapon systems, aligning with the requirements and capabilities of its international partners. The primary propulsion system of the F-35 Lightning II is the Pratt & Whitney F-135 afterburning turbofan engine. The F-135 engine delivers 28,000 pounds of thrust in dry thrust mode and up to 43,000 pounds of thrust with full afterburner. It is located in the middle rear section of the aircraft's fuselage. The engine's performance allows the F-35 to achieve a maximum speed of Mach 1.61 and operate at altitudes of over 50,000 feet. The rate of climb and specific G limits vary based on the specific variant of the F-35, with the F-35A model having a 9G limit rating. For the F-35B variant, which is designed for short takeoff and vertical landing operations, a unique propulsion system is employed. The Lockheed Martin patented shaft-driven lift fan, SDLF, is utilized to achieve vertical flight capabilities. The SDLF is produced by Rolls-Royce Corporation and consists of the lift fan, a clutch, two roll posts, wing-mounted thrust nozzles for roll control, and a drive shaft connecting the lift fan to the power plant. The SDLF works in conjunction with the three-bearing swivel module, which is a thrust vectoring nozzle located at the tail of the aircraft. This system enables the F-35B to transition from conventional flight to vertical flight and back. The lift fan, powered by a two-stage turbine on the engine, generates up to 20,000 pounds of lift, accounting for nearly half of the total thrust required for vertical flight. The lift fan also provides cooling for the downward drafting air, which is an improvement over previous STOVL aircraft designs. Airflow through the fan is controlled by variable inlet guide vanes. The F-35 Lightning II incorporates advanced systems and technologies that significantly enhance its operational capabilities. One of the key systems is the Electro-Optical Distributed Aperture System, DAS, developed by Lockheed Martin Missiles and Fire Control and Northrop Grumman Electronic Systems. The DAS provides the pilot with a comprehensive view of the battlefield from all angles around the aircraft. It can detect and coordinate enemy aircraft, air-to-air and surface-to-air missile launches, and ground explosions. The system enhances pilot situational awareness and supports day and night missions. The F-35 is equipped with an electro-optical targeting system, EOTS, located on the underside of the nose assembly. The EOTS, also developed by Lockheed Martin and Northrop Grumman, enables the pilot to detect and track targets accurately from greater ranges. This system enhances the aircraft's combat capabilities and contributes to its effectiveness in the battlefield. Stealth technology advancements are integrated into the F-35, building upon the lessons learned from Lockheed's F-117 Nighthawk stealth fighter. The engine nozzle is designed to be stealth-friendly and axisymmetric, reducing radar signatures and maintaining a minimal profile. These features enhance the aircraft's ability to operate covertly and avoid detection. The F-35's avionics suite, developed by Northrop Grumman Space Technology, includes a modular system that facilitates data sharing between the aircraft and ground-based allies in real time. The aircraft features a satellite data link, providing beyond line-of-sight communications and web-enabled capabilities. This robust and adaptable communication system was developed in collaboration with the program's international partners. The F-35 is equipped with an advanced APG-81 series active electronically scanned array radar, developed by Northrop Grumman Electronic Systems. This radar system enhances the pilot's situational awareness by detecting, tracking, and engaging targets on land, sea, and air at extended ranges. The radar can operate in both active and passive modes, further expanding its capabilities. The Distributed Infrared System, DIRS, comprises 6 internal sensors mounted around the aircraft's airframe. These sensors provide an infrared image of the aircraft's surroundings directly into the pilot's advanced helmet-mounted display. The DIRS enables the pilot to have a full 360-degree situational awareness, allowing them to see through the aircraft. The F-35 features diverterless supersonic inlet ports, which eliminate the need for moving parts and reduce weight. These inlets utilize a bulge along the fuselage side to spill off turbulent boundary layer air that builds up along the intake lips. The aircraft is equipped with a helmet-mounted display system, developed by Vision Systems International. The advanced helmet eliminates the need for a conventional heads-up display and delivers critical mission and system data directly to the pilot's visor. The pilot can track and engage targets without necessarily facing them. The cockpit incorporates an 8 inches by 20 inches panoramic multifunction display system that provides real-time information and high-resolution motion imagery. The cockpit also supports direct voice input through a speech recognition system, and the flight control is achieved through a conventional hands-on throttle and stick setup. The F-35 Lightning II's onboard systems are highly configurable to adapt to various mission requirements, including air superiority and ground strike, providing the pilot with flexibility and effectiveness in combat scenarios. The aircraft's communication capabilities are also top-notch. It incorporates state-of-the-art tactical data links that enable secure sharing of information among other F-35s and various airborne, surface, and ground-based platforms. This allows for effective coordination and collaboration between different assets during joint operations. Reliability and maintainability are critical aspects of the F-35's design. The Autonomic Logistics Information System, ALIS, is a sophisticated support and training system that integrates various aspects of the aircraft's performance, maintenance, and planning. ALIS performs behind-the-scenes monitoring, maintenance, and prognostics to ensure the aircraft's health, optimize operations, and enhance mission planning and execution. The F-35 Lightning II has been developed into 3 primary variants, the F-35A, F-35B, and F-35C. These variants share a high degree of commonality, with up to 80% common parts between them and a near 100% common avionics suite. This approach reduces costs associated with production, maintenance, and upgrades, making the F-35 more efficient for operators. The F-35A is the conventional takeoff and landing variant primarily designed for the United States Air Force and serves as the base export model. It features an unrefueled range of 1,700 miles without external fuel tanks. The F-35A is armed with a fixed internal 25mm GAU-22/A automatic cannon, and has 2 internal weapons bays. It carries air superiority armament, including a pair of AIM-120C AMRAAM medium-range air-to-air missiles, and ground attack capability with a pair of 2,000 pounds GBU-31 JDAM precision-guided bombs. The aircraft can also carry external ordnance on optional underwing hardpoints, expanding its mission flexibility. The F-35A has a wingspan of 35 feet, an overall length of 50.5 feet, and a wing area of 460 square feet. Its internal fuel capacity is 18,498 pounds. The F-35B is the short takeoff and vertical landing variant developed primarily for the United States Marine Corps and the Royal Air Force/Royal Navy services. It combines stealth technology with the ability to land and take off vertically, allowing it to operate from various surfaces, including moving warships and unprepared airfields.
The airflow in and out of this lift fan needs careful consideration. The lift fan is essentially a tiny helicopter, capable of generating 85 kilonewtons of vertical thrust, and in doing so creates a low-pressure zone above the plane, violently sucking air into the aircraft at a 90-degree angle. This air has to travel over the hood to reach the inlet, and thus the hood needs to allow air to smoothly pass over it without creating too much turbulent flow, which would lower the performance of the lift fan. This is why the inlet door is not serrated, as the sharp edges would cause distortions in the flow. This hood alone went through several design iterations to optimize the airflow flowing over it. This helps funnel air into the engine and improves pressure recovery on short takeoffs where the F-35B does not take off vertically, instead using the lift fan and directional thrust of the rear nozzle to take off on extremely short runways. The way this aircraft transforms to perform vertical landing and short takeoffs is astounding. It's the closest thing to a transformer we have ever created.
The F-35B has a range of approximately 900 miles on internal fuel alone. It is armed with 2 AIM-120C AMRAAM air-to-air missiles and 2 1,000 pounds GBU-32 JDAM guided bombs stored in internal weapons bays. Additional armament options include air-to-surface missiles, munitions dispensers, and GBU-38 bombs. The F-35B incorporates the unique lift fan system described earlier, allowing it to achieve vertical flight capabilities. It has a wingspan of 35 feet, a fuselage length of 50.5 feet, and a wing area of 460 square feet. Its internal fuel capacity is 13,326 pounds. The F-35C is the navalized variant specifically designed for aircraft carrier operations by the United States Navy. It features a revised undercarriage and internal structure to withstand the rigors of carrier operations. The F-35C is launched from carrier catapults and utilizes a conventional arrestor hook-and-wire system for landing. It has larger control surfaces and folding wing tips for improved low-speed performance. The F-35C has a range of 1,200 miles on internal fuel alone. It is armed with AIM-120 AMRAAM air-to-air missiles and 2,000 pounds GBU-31 JDAM guided bombs stored internally. Like the other variants, it can carry a range of air-to-surface missiles, bombs, and guided munitions. The F-35C also mounts its 25mm GAU-22A series cannon in an external pod. It has a wingspan of 43 feet, a length of 50.8 feet, and a wing area of 620 square feet. Its internal fuel capacity is 19,624 pounds. These 3 variants offer different capabilities and fulfill the requirements of their respective operators, providing a versatile and adaptable platform for a range of missions. International cooperation is a fundamental aspect of the F-35 program. With involvement from 9 partner countries, the F-35 represents a model of international collaboration in defense. This collaboration not only enhances security, but also promotes cost sharing, technology sharing, and interoperability among allied forces.
Here, I'm really proud of the team that we've brought with us. We have some exceptional maintainers and pilots, highly experienced in the F-35, and we're really looking forward to working with the Lockheed partners.